So I believe this was what I had probably gone over on Thursday. And then Friday we talked about how to lower our taxes based on a couple of things. I mean, that's actually a long conversation. Hello. A long conversation, many Fridays, that we could talk about just taxes because, one, I do know, I see all of the things that are posted on memes. They only taught me this in school. Well, I'll take the memes to heart and show you some of those things because I can tell you, me as an adult me, I like when you can say, Chris, because that's my name, here are your three options, and I get to choose the best option that works for me. So that's kind of some of the stuff. All right, so help me out. I don't recall, and you guys recall better. Did I work out any of these problems at all on this worksheet? Nope. Cool. All right. So let's take a look at it. All right, so this first problem, if you were graphing on the TI graphing calculator, they say to have this as your window. We don't have to worry about that on Desmos because it's going to take care of it for us right away. Okay? So I'm going to jump onto Desmos. It says sketch a graph of each, label all key points, intercepts, max, min, asymptotes, etc. Okay. So let's pull up our favorite buddy and pal Desmos. And let's just take a look at what this graph is going to look like. So y equals x squared. Bring it down. Ooh, that's a 4x squared, isn't it? Plus 5x minus 6. And so they want us to focus in on all the important points of this particular graph. Okay, so they want us to focus on x-intercepts. Do you feel comfortable with that being the x-intercepts? They want us to focus on the y-intercept, which just hover down there, and there's your y-intercept. And then they want us to focus on the minimum. And this is when we have max and mins in math, and then we have local mins and local maxes also in math. This is a local minimum because that's the lowest the graph goes. The local minimum in this case is actually truly the true minimum. But, and a lot of times when we talk about the minimum, if you, in this class, if you gave me the point, you're perfect. In future math classes, they might ask you to say what the minimum is, and you give the y value. So it's not vitally important if you know just, if you're like, gosh, I can't remember what you said do the x, y, just give me the whole point. Okay? So when you're writing these, it's just pretty simple, and I'll just annotate on top of here. So this is a local min, but in this case, it is just the minimum because the graph will not go any lower. A lot of times the local min is when it's a third degree where it goes up, down, up, or something like that. Both of these values are the x-intercepts, or you might call them solutions. And this is the y-intercept. Okay, that's basically all you could really talk about with that point. As far as on the test or quiz, I'm not going to ask you to sketch the graph of something. I want you to use the points to say what they are. So, hey, we have solutions, which are the x-intercepts at here and here. We have a y-intercept, which is this. We have a local minimum, which is this. And that's it. You don't have to go and, take what Desmos was showing you and try and graph it, okay? You just go with it. Sometimes if I give you a quiz like on Schoology, I might have graphs put in, and you might have to select graphs that come with it. That kind of falls into when we start doing derivatives, because the derivative graph looks a little different than the actual function. But we go with that. Okay. Does everyone feel good about number one? let's jump down to number 3. Number 3. So does anyone know what those vertical brackets are that are grouping x plus 2? What are they called? Absolute value. So on Desmos, you could type absolute value, okay? Or you can do this, go into your mode and look for the absolute values, which is this. And we have x plus 2. Oops, go inside there. X plus 2. And then arrow outside of it, and then we have minus 3. Okay. So this should indeed look like a V. It should look like 2 straight lines or rays that are going from the same point. So you have x values there and there. You have this as a y-intercept, and you have this as a local min, local max. Let's trash that. Okay, so -2, -3 is a local minimum. It's the lowest value you have. 0, -1 is the y-intercept, and the solutions or the x-intercepts are -5, 0, and 1, 0. And that's really all you have to put about this graph. Does that make sense? And if you try that on Desmos, did you make it work? Does it make sense how to make it work? Again, the nice thing is, if you've got like 70% of this, and you're working with somebody who's got another 70%, and somebody else has got another 70%. Hopefully the overlaps of all the 70% get you to having the understanding of what the entire answer is, which is great. All right. Yeah. Okay. Which one do you want? 8's the more difficult one, so you got it. Let's take a look at number 8. All right, so number 8, we want to make a fraction, so you just use the fraction key or the divided button. And then on top we have x, and on bottom we have x squared, and then -9. Holy moly guacamole. Okay, there's a lot going on with this graph. Do you agree? So anytime you see your lines going forever vertical or up or forever vertical down, that means there's an asymptote that takes place. So the vertical asymptotes for this type of problem are when the denominator is equal to 0. Okay, so I'll say it one more time. Vertical asymptotes, they are these vertical lines that you don't really see them. They just kind of exist, are where the denominator is equal to 0. So if you were to kind of think about this, you're looking at the very bottom. Did I do it? Yeah, 3 and -3, actually, yeah. If I plug 3 in, I get 3 squared. 3 squared is 9. 9 minus 9 is 0. 0 on bottom, 0 underneath. It makes an asymptote. And then -3 as well. If you take -3 and plug it in and get past algebra 1, if you plug a negative into a something, that should be in parentheses, so you're squaring it. So -3 quantity squared is 9. 9 minus 9 is 0. So we have these vertical asymptotes that are indeed taking place. And the nice thing is if you think you know what the asymptotes are, Desmos allows you to do vertical lines. And that's a huge plus to Desmos. Now the blue and the green line are not part of the graph. They're just mimicking what the asymptote would be. That's where as I'm going up or I'm going down, I'm getting really close to the green or I'm getting really close to the blue. And those are vertical asymptotes. Okay? This particular problem also has a horizontal asymptote. And one of the rules for a horizontal asymptote are if the degree on top is smaller than the degree on bottom, so the degree on top is x to the first, the degree on bottom is x to the second, the degree on top is smaller than the degree on bottom, then y equals 0 is our horizontal asymptote. And the goofy thing about this is that purple line, and here's the silly part of this. An asymptote, you've been told, is something you can't cross. But there are times horizontal asymptotes are crossed. It does indeed cross at 0, 0. Okay? So this point does indeed exist as far as that goes. And I was just trying to talk about what that says. And then it says solve each inequality. Okay, so let's go and solve this. All right. It says, where is this graph less than or equal to 0? Meaning it's below the x-axis. Okay? So if I do this, y is less than or equal to 0. I think that'll work. Yep, there we go. So that's what I'm basically doing with this graph. Actually, I need to go the other way. Yep, no, we're right. We're correct. I'm sorry, I had a temporary lapse of judgment. All right, so now we need to say, where does our graph exist below the x-axis? So as I'm traveling in the x direction, that's the right-left direction, you're going to say what it's doing in the y direction. So as I come from negative infinity, so this region right here, as I come from negative infinity and I approach -3, and that's a round bracket on both of those, because I will never get to the -3. That's the first part of this graph. Okay? And then the next part of the graph, when you look at it, I'm going to circle this region here. Okay? This region here is going from -3 to +3. Those are using soft brackets because I'm approaching the -3 to the left and I'm approaching +3 to the right. Okay, that is not the point, -3 comma -3. Okay, so those are all the domain. And then the last one, if I look at this part of the graph, this is going from soft bracket 3 to infinity. And things I want you to notice, I have a -3 here, I have a -3 here. That tells you right away that the vertical asymptote is at -3. When you have a +3 here, and then you list a +3 here, that tells you that you have an asymptote, a vertical asymptote also at +3. Okay? So that's basically where the graph is underneath. And I just realized I made a mistake. Does anyone see the mistake? It's in the red. Yeah, it's actually 2 mistakes. So this one, this should be 0. Because that's where it starts going below. And I made a mistake in the green as well. What can you tell me about the green? Is it above or below the x-axis? It's above it. So this is above. Okay, so that's above the x-axis. This is below. And then this region over here is below. And that's why we have to list it as 0 to infinity. I would say it's a soft bracket at that 0, because if you're exactly at 0, that means your y value is at 0, and 0 is a signless number. 0 is not positive or negative. Like, well, it should be because, you know, if you go 0, 2, 4, 6, 8, that's even numbers. You're right. But 0 is signless. So that's why it has to be soft bracket. Ooh, make a note on that. Make a note on that. We doing okay? Everyone's still pretty happy? So that's where it's less than. So it might have to do with the domain. That's what I kind of listed on that problem. And let's see. 9, 10, 11, those are all domain. So you're telling me what's going on. in the from the X direction to where. I think you can do the rest of those. If you have questions about those, why don't you take this time to work on all the problems. It does have the problems listed below the answers at the bottom of number 13 are the answers. But if you're not matching those answers, one, it's possible you did it correctly and we did the answer key wrong, or maybe you made a mistake. So why don't you finish that sheet? You have the rest of the period to work on it. Show me before the end of the period and we'll call it good and give you the points for it. If you still needed some extra time, then you can get the same points for tomorrow. Deal? Save.